Well, let's see. In this problem here, we've got a parallelogram. And parallelogram, this two opposite sides are parallel. This is the base, and this is the height. And we're already given an expression for the base and the height, right? So the whatever x is, the base is 3 times that value and 1 more, and the height is that value plus 1. And we're given the area formula for a parallelogram. Turns out it's the same as that of a rectangle. So let's see what we can do here. What we're trying to do is find the base and the height. So how about if we start here? We know that we'll start with our formula. The area is equal to base times the height. And we're given here that the area is 65 square units. So let's write, now look, just bring this straight down. Just bring everything straight down. If there's a formula, write the formula, and then bring all the numbers, just substitute them in straight down. So area is 65 equals the base. Now here's the base, 3x plus 1, so we'll write that one. And the height, right? And the height is that x plus 1. So let's multiply these out here. So we're going to get 65 is equal to 3x squared, and the outer product is 3x, the inner product is 1x, so 3x and x is a 4x. And the last, 1 times 1, that's going to be a 1. This is quadratic, right? We've got a squared term, and it's over here on the right side. Why don't we eliminate that 65 and get everything on the right side, 0 on the left side? So what we're going to do here, our plan will be to subtract that 65, and things will look like this then. 65 minus 65 is a 0, equals 3x squared plus 4x. Now, we've got a 1 minus 65 gives us a minus 64. So this is quadratic, right? We know how to solve quadratics. We've got 0 on this side, everything else on the other. Let's factor. So we're going to get 0 equals... Now, what are we going to get here? Well, it'll have to be a 3x and an x. Now, for 64, for this 64 here, we could use 64 and 1, 32 and 2, 16 and 4, right? I'm just cutting in half and double. And then 8 and 8. Okay, I think we might have them all. So which one are we going to start with? Well, we could try the 8 and the 8 just because these are closest together. But if we try 8 and 8, well, I don't know. Let's see what happens if we put that 8 and 8 in. We'll get an 8 and an 8, but then what do we get here? We get 24x and 8. 24 and 8, we can't get that 4 out of. So this is not going to work. Let's try something else. We'll get 0 equals... All right, let's go with 3x and x. And now I'm going to go up and I'm going to try this pair here, 16 and 4. And, you know, I don't think I'm going to put the 16 here because it gets multiplied by 3. And that's 48. That's pretty far away from the 4. So if we're going to try this, let's put the 16 here and the 4 here. Now, is there a chance that this could work? Outer product is 12x. Inner product is 16x. Well, 12 and 16... we can get a 4 out of that, right? Let's just get the sign right. 64 is negative, so these two numbers have opposite signs. And we're going to put that middle plus sign with the bigger of the two products. And the way this one's written, the outer product is 12x. This is bigger. This is 16x. The inside is bigger. So let's put that plus sign with this one. So we're going to get plus 16x minus 12x is plus 4x. Let's read off the solution now. X is equal to, right, change the sign and divide. So we'll get negative 16 over 3. And from this one, we'll get x is 4, right? Change the sign and divide. Positive 4 over 1, so we just get a 4. And now it's a word problem, so we follow it all the way back to the beginning to see what x is. So here's our x's. So we are going to get, what do we know? Well, x is what? Well, it's part of a height and a base. So we're not going to have a negative number here. So we can cross this negative out. and then we'll go with a 4. So x is 4, so we're going to conclude now that x is 4, so then what do we get for this? What do we get for the base? The base is 3x plus 1, so let's write that. So what is 3x plus 1? Now there's the x right there. So we get 3 times 4 plus 1, looks like 13. And then, what do we get for the height? Well, the height is x plus 1, so let's write that here. So what is x plus 1? Well, x we determined is 4, so 4 plus 1 is 5. So now, let's say, here's what we'll have here. We'll say that the base is 13, and 13 units, whatever the units are, and the height here is the 5 units. Let's take a look at 31. Now there's a difference here. In 30, we were given the base and the height. That was already given to us. But in 31, we're not. We're just given some relationships. So let's read it over. It says the area of a triangle. Now, as soon as I see triangle, I've got a drawing that I can make, right? So let's draw a triangle. So any triangle will do. It doesn't matter. Just draw some triangle. Doesn't even have to be to scale. So here's a triangle. And then it says, okay, the area is 110 square inches. So here's what we do know this right away, and we can write this, that the area is 110. Now I'm just traveling along here, seeing what's happening. The base, right, maybe the way I drew it, here's the base. The base of the triangle measures 2 inches more than, oh, there's that more than. And we know how to work with more thans, right? There's that more than. And with more thans or less thans, whatever follows the word than, that's our starting point. So just read this and write what you read. So here's where we're going to start. Twice the height of the triangle. Twice the height. Now, that's going to tell us we should let x equal the height. So I'm going to draw that in here. So the height goes from the base, perpendicular from the base, up to, so a height goes perpendicular to the base up to that opposite vertex. So let's let that be x. So this will be x. And I'm getting that, right, because it's following the word than. What follows it? Twice the height of the triangle. So let x equal the height. And then, what about the base? We'll come back here. The base is 2 inches more than. Okay, so here's where we start. Twice the height. So let's write it. Twice the height. And 2 more, right? It's 2 inches more than twice the height. So here is twice the height, and it's 2 more. So 2 more than twice the height, and that is the base. All right, so the base is that number right there. Now, here's what we need to know. We need to know that the area of a triangle, is 1/2 the base times the height. So let's move on here. Here's what we know. We're given this, that the area is 110. Let's substitute that right in here. So we're going to get 110 equals 1/2 the base, and we just determined the base is 2x plus 2 times the height, which is x. Now, here's the equation. We've got the equation. That's the critical part. We've done really the hard work. Now we just have to do some engineering and solve the equation. The equation has a fraction in it, and we know how to handle these fractions, right? You get the LCD, and you write the LCD in front of every term. So let's see what we have here. I'm claiming that the LCD is 2, so I'm going to write the 2 in front of this term and in front of this one. So let's write it. Here's what it looks like. 2.110 equals 2.1/2 2x plus 2 dot x. On the left side, the 2 times 110 is 220. On the right side, those 2's cancel, and we're left with what? 1 times this. So that's just 2x plus 2 times x. Let's multiply through. 220 equals, now multiply through, we'll get 2x squared plus 2x. This, as you can see, is quadratic, right? You got the squared term on the right side. Let's get rid of this. Let's subtract 220. So we'll subtract 220. 220 minus 220 is 0 equals 2x squared plus 2x minus 220. 0 equals, now we can factor a 2 out, right? All of these terms are even, so let's factor out a 2. Doing that gives us an x squared plus x minus 110. See if we can factor this. We'll get 0 equals 2 times, all right, x and x. Now, look, this ends in a 0, so the way this is going to work is we're probably going to have like a 0 in one of our numbers. And what about 11 times 10? Okay, I mean, you could try the 110, cut in half and double, cut in half and double. But I think we're going to eventually get down to 11 and 10. So this is going to be 11 and 10. Is there a chance that this could work? Look at the outer and the inner. 10x and 11x. I can get a 1 out of that. Let's get the sign. This is negative. So these two numbers have opposite signs. I'm going to put that middle plus sign with the bigger product. That's going to be this one, right? 11x, that's only 10x. So put the plus here. So we'll get plus 11 minus 10. And the solution to that equation is negative 11 and 10. Do you believe it? The 2 has no effect. What's going to make this 0? Negative 11, right? Change the sign and divide. Negative 11 over 1. Change the sign and divide. Positive 10 over 1. So here's our solutions. But it's a word problem. So follow it all the way back to the beginning. What is x? All the way back up here. X is the height of this triangle. And the height of a triangle cannot be negative. So let's cross that negative. So we're going to claim that x is 10. So the height is 10. Now we still have to get this one, right? We have the 2x plus 2. Let's just put it right down here. Just write it right below. 2x plus 2. And there's the x right there. So this is 2 times 10 plus 2. 20 plus 2 is 22. So now let's say what we have here. The base and the height. Okay, so the base is going to be this 22. And I think we're dealing in inches. And the height is going to be the 10 inches.